Thanks, everyone. Today we're going to be talking about using AI to test software techniques and tools. And thanks, Voxel51, Jimmy, and Dan for having me. Excited to dive in. So before we dive in, a little bit about me. But before I founded SoftwareTesting.ai, I was an early engineer at the telehealth startup Caregility, and then became their VP of software development in late 2021. Before Caregility, I was at Loon, which is now a deprecated Google X project, and I graduated from Stevens with my bachelor's and master's degrees. Couple fun things while not working. I like barbecuing, playing board games, and beating my friends in fantasy hockey, especially this season. Um, so yeah, let's dive in. So what we'll cover today is the struggle with testing. What are the problems that engineers are encountering with testing? Go over kind of the testing pyramid and the different types of automation tests. I have an example application with test code. I wasn't able to screen share on my Linux computer, so I'm on my Mac, so I can't give a live demo of that, but we'll definitely share that link after. And then we're going to go into using AI for unit testing, integration testing, and end-to-end testing, and then talk a little bit about software testing AI. So with that, let's dive in. So I think all developers recognize that testing is important, and the quality of our code that we're writing is important. But a lot of us are struggling with test coverage. So just some statistics, right? So 47% of teams don't have full test automation coverage, or only 47% of teams have full automation testing coverage. So that means over 50% don't. A majority of teams don't have a full automation test suite, and they're struggling to get there. And there's a variety of reasons, like sprints leaving little time and room for testing. Unreliable tests are kind of reducing some trust in automation, especially at the higher levels in the testing pyramid, which we'll talk about. Testing is often deprioritized for feature development. This happens at a lot of smaller companies and startups where the need to ship quickly is higher priority than the need to ship quality. And additionally, a lot of developers just don't have a testing kind of QA type of mindset. And then one of the other reasons too is that keeping a robust automation test suite up to date and current is a lot of work. It's a lot of work to maintain tests and maintain a test suite, especially if you have something that's comprehensive with end-to-end testing and different types of API testing. And engineers are trying, but it's not working. Testing's a top 5 reason for release delays. It's something where I've seen it many times myself, and I've heard from a lot of other companies, they're struggling with testing, and they're struggling with testing leading to a delay in their releases. So it's something where there's a real world impact to a non-robust test suite or testing not be an efficient process at companies and with engineering teams. So let's dive into the kind of general sort of guidelines around testing with the software testing pyramid. So that this may be familiar to some of you, where Martin Fowler and Mountain Goat Software, they came up with this software testing pyramid, and it starts with the bottom layer, which is unit testing. This is kind of the foundation for the testing pyramid, where you're testing individual components. These are the unit tests that you write for your functions, your classes, your methods, and it's where all the other tests build on top of. So after your unit testing layer, you have your integration testing. And integration testing is where you're testing APIs, webhooks, different types of messaging. That is sort of the main layer of integration testing. There's also some security testing being done at this layer, depending on the company and the team you work for. So that's something else that's common in the integration testing layer. And then at the top layer, you have your end-to-end tests. And these are your UI workflow tests. So using tools like Puppeteer or Selenium, you're actually simulating a user clicking through your application, and from there, trying to mock out what a user would do and user behavior. Um, and keeping a robust test suite maintained, with all three of those layers in the pyramid, and it could be broken up into sub layers as well, is a lot of effort. And that is what a lot of developers are struggling with. And this is where AI could come in and help, with making testing more efficient, helping engineers write tests more efficiently, and also help engineers write tests more effectively. So I do have a sample application and sample code, which we won't be able to give a live demo of today, but because of the Mac Linux issue, but I'll send out the link so you guys could view all the test code, all of the prompt engineering behind the prompts that generate the test code, so that you guys could use them in your own projects, and hopefully help you guys test a bit better. So before we dive into specific, AI assistance for the different layers in the testing pyramid, let's dive into a general rule of prompting. I'm sure all of you know this, but garbage in is garbage out. And this is especially true with prompt engineering and test cases. If you just copy and paste your code and say, hey, write a unit test for this, odds are, like a GPT type of model or a BARD type of model is going to give you something that is unusable. The code style is probably not going to be aligned to the code style your team is using. The functionality, of just the test, like will it run and will it execute? It probably won't. The cases that those tests are covering, probably won't be the highest quality test cases possible. It probably won't be testing edge cases or corner cases, that your function might have, or the application code you're trying to test might have. So prompting really matters heavily, when you're trying to use these AI tools for testing. And what we'll dive into is what are some prompts and what are some kind of general tips for writing effective prompts to get good outputs from these types of models. So let's dive into to unit testing. Uh, so with unit testing, some general tips is provide the function, the class, the method, as context, but be prepared to provide more code as context. So like what I gave the example earlier, don't just copy and paste a function and say, hey, write a unit test for this. It's better to engineer your prompts to have something where you're telling the model to act as an expert in the field. So as well as to look out for certain things when writing the test so that it keeps it in mind. Um, so for example, one prompt that works really effectively for me and some of the companies that we're working with is, act as an expert developer who's experienced in JavaScript unit testing framework, testing and testing best practices with the Jest framework. So what this is doing is you're calling out that to act as an expert developer in JavaScript. So the application code instance is JavaScript, and test best practices with the Jest test framework. Then you say, I need your help to test the application code below by writing unit test cases for it. While writing the test cases, please keep this in mind. Then you go into corner and edge cases that should be tested. It would be helpful if you add, so if you've identified saying, hey, I think these corner cases really need to be tested, adding that context in there, mocks that need to be created, as well as industry best practices for writing unit tests. There's a lot of actual standards around writing unit tests, that are in the model training data. So for example, there's an ISO standard, there's an IEEE standard, and but by telling the model to use industry best practices, I've been finding that the outputs are typically more aligned, with those guidelines from IEEE, rather than just kind of code that uses the test framework. Also mention that, use industry best practices for code style. And what's really helpful here as well is if your team has a specific testing or a code style guide that you guys are using. So the last company I was at, we used the Airbnb style guide for JavaScript to actually state what style guide to use. Because a lot of times that's, again, part of the training data for these models is the code style and the code style guidelines. So then you mentioned where there are parts that have an import, need mock data, other stuff like that, to write the skeleton for it and then add a comment. So in the code that it generates, it won't just generate blanks there, or it won't look off. It'll have kind of the skeleton there for you, and then it'll add a comment on the same line saying, hey, we need to know the file path for importing this library or something like that. And then from there, you paste in the application code as well as other code for context. It's a very detailed prompt, but I found that this type of level of prompting, it gets you a lot closer to the quality of a unit test that you expect and you need, rather than just copying and pasting your code and saying, hey, write a unit test for this. So kind of building off of that, some tips, right? These types of models, they could very easily write tests to check types. So for example, like with JavaScript, where it's not type sensitive, but you might get runtime errors. Having existing test cases and then saying, hey, I need to add a test to make sure this is not a string or something like that, or what happens when a string is passed in. It's very good at writing those types of tests, and you can very easily engineer prompts to help you with that and speed that up and get those kind of like easy cases covered, as well as describing the input and the output. So the more context that you provide the model about the input and outputs of your functions or classes or methods, the better result you're going to get from the AI tool. If you go to the GitHub repo, you'll be able to see the unit tests along with the prompts for those unit tests that I was able to generate with GPT-4 to showcase how to test effectively different components. So let's dive into integration testing, right? So integration testing are those APIs and the hooks testing at that layer. So for this, AI is pretty good at writing quick checks for status codes. So asking it explicitly for saying, hey, can you validate a 500 error? When that's returned, what does that look like? Can you validate a 201 created success message? It's very good at mocking those out, as well as writing that test code, as well as it's helpful to specify like what HTTP method is. So this is obviously in the application code itself, but giving it more context about that is helpful, especially if the same API endpoint supports multiple HTTP methods, as well as timeouts. So timeouts is actually one thing that was pretty tricky to test at one company I was working with. About the API that we were calling, it had to perform a lot of logic, and it took a while for it to return a response. So with that, it's important to let the model know like what is the timeout that should be expected. So yeah, diving into the prompt here. So again, it's using that act as an expert developer sort of model, and then it's saying experience in JavaScript REST API integration testing and testing best practices. And the same thing as we had before, but a little bit modified is I need your help to write tests for the APIs below. While writing the test cases, please keep the following in mind. And then from there, you put in your corner cases, the different types of REST request methods, and then different types of response codes, both success and the error codes we talked about that the API might support. As well as industry best practices for writing API integration tests. So this is another part that's actually covered by those IEEE standards, and by including this line right here, I found that the tests that are generated are more aligned with those standards. and as well as the industry best practices for code style, which we talked about, and talked about that if you are abiding by a certain code style for your team, including that one in there, because most likely it's probably trained on it. And then you put in the code or the spec for the API that you want tested. So I found that you could not only put in the actual code of the endpoint or of the request there, but also say, for example, you're using the Open API standard and you have like a Swagger file, or say you have a Postman collection and you export that Postman collection as JSON or YAML. By actually putting those specs in and then in the prompt specifying what API test framework you want to use, you'll actually get pretty solid outputs as well. So with this higher level of testing, you don't necessarily need to provide direct code. You could also provide those types of technical spec files. And you'll see this as well with the end-to-end testing is the end-to-end testing, you could either paste in, say, code for your components, or what you could do is you could tell it which HTML elements to interact with and how to interact with them. Is it a text box? Is it something that a button that needs to be clicked? And again, the code for or the code that is generated with this prompt, as well as other prompts, are included in that GitHub repo. So yeah, so end-to-end testing. So with end-to-end testing, this is the layer of testing that is the user workflow level, right? That's mocking out or simulating user journeys within your application. So with this, what you want to do is you want to provide as many details as you can about what that workflow is and what you want the user to achieve. And the more specific you are with this, typically the better. As well as specifying UI elements that you want clicked. So you could not only put in, or feed the code to the model as context, but you could also feed in like what are the HTML elements, and then from there, what actions do you want the test runner to take with those different HTML elements, as well as again edge and corner cases. So this is something where it's actually very, very convenient to have AI write test cases for edge and corner cases at the end-to-end testing level, because a lot of times, especially with at least what I've seen in early applications and startups, there's a lot of buttons that might not fully work, but they kind of work. And there's also some workflows that you don't expect users to click on things, and they end up clicking on things. So having AI write some of these test cases where it might not make sense for a developer to actually fully flesh out these test cases is pretty nifty. And again, going into the prompt for this one, and you could see the test code generated from it, and the other prompts I used for it is act as an expert developer, and that is proficient in end-to-end UI testing using Puppeteer and JavaScript. So Puppeteer is one of the popular UI test runners, similar to Selenium. And then you specify the workflow. So I need you to write test scripts for the following user workflow, and then it's logging in and searching for a user profile. Then please ensure that the test scripts include validation for successful login and navigation to the dashboard. Keep in mind industry best practices for end-to-end testing and code style. So this again goes to those IEEE standards that were written about testing holistically that had subsections for unit integration and end tests. So this will make sure that it kind of aligns closer with that, as well as the code style, like we talked about a few times, is add in the code style guide that you guys are using or you guys are abiding by. And then adapt the scripts to be flexible enough for varying UI elements. And then here's the application context. And this is where you could paste in either the actual, say for example, you're using React, you could paste in the code for the React components, or what you could do is you could write a description of the scenario with the HTML elements, as well as what actions you want the test runner to take with those HTML elements. So that's a bit on end-to-end testing, and that's the testing pyramid. Um, Now, a little bit about software testing AI and how we could help. This is the specific product that I built for using AI to help accelerate developers and their ability to write unit tests. So what we do is we identify your unit test coverage gaps inside of your CI pipeline. So just like how, say, a tool like CodeCov or Coveralls will spot out for you what the gaps are in your application code in terms of like your test coverage gaps. We're able to identify those as well. But what makes us a little bit different is that we also help you fill them. So what we do is we take the result of identifying where your test coverage gaps are, and then from there we use AI to actually recommend unit test cases to cover those gaps. So in this instance, where we identified a code coverage gap, we added a comment to the GitHub PR saying, hey, we have a code coverage gap here. Here's some code that will help cover it. Please considering adding those test cases. So we keep building out the product every day, trying to improve the quality of test cases that we're generating, as well as the ability to identify coverage gaps and assess your current test quality, and using some of the prompts and techniques that we talked about here, as well as others, and including fine tuning and backfilling models to generate really solid test cases that they might not be 100% of the way there, but they get you 70-80% of the way there with writing that test code, so that you can modify it a little bit or directly just copy and paste it into your test file. So yeah, that's a little bit about software testing AI. I apologize again, the demo didn't work on because of the Linux Mac thing, but we'll definitely share the GitHub repo so you guys could take a look. And thanks again also to the Voxel 51 team for having me speaking. So thanks, and any questions?
Yeah, thanks, Justin. It does look like you have one question in the Q&A widget from Christian.
Awesome. Okay, so the question is, what are the main issues having AI doing the testing as opposed to have the developer doing the testing? So I think having AI solely do the testing, right? So having the AI be the only one writing test code would have some issues, right? So for example, it's always helpful to have a developer's experience where they having written the code themselves, know what the edge cases are they want tested, how they want things tested. So the way that I view it is kind of like AI augmented testing, where you give us a specific prompt or we identify specific gaps in your code coverage. And then from there, we work with you to get that test code written, but written much faster. So I think there definitely is issues with having just AI doing testing for you, that could stem around test quality. What are being actually tested? Is that actually valid tests? Things like that. But the way I look at it is, AI should augment your ability to test and not replace it.